Hi everyone. In this lecture, we will integrate the Elastic modules that we created in the previous lectures with the microservice Kafka to Elastic service. Let's first add all the Elastic modules as a dependency to Kafka to Elastic service. Elastic module, Elastic config, and Elastic index client. We will define the versions for all these three dependencies in the main POM.xml file, as we always do. Then we can use these dependencies in the Kafka to Elastic service POM.xml file without defining the versions. Let's start adding a component, our to Elastic module transformer first. So we will create a package transformer and create a class our to Elastic module transformer. We will use this class to convert our model to Elastic model, as we need to obtain a model that fits to Elasticsearch. We will create a method called getElasticModels, which will take a list of Twitter hour model as parameter, and then return a list of Twitter index model. Let's create a stream of Aura models and use the builder on the Twitter index model class to set user ID, ID, and text. For created fields, we need to convert the long variable to a local datetime instant. So we will use local datetime of instant methods, and then use instant of epoch milli methods to get the milliseconds from created field using the system default zone. Then we will build the Twitter index model object and then collect the result stream to a list of index models and then return it. Then let's go to Twitter Kafka Consumer implementation class, where we have the Kafka listener. And then inject the transformer class that we just created, as well as the Elastic Index client that is created in the previous lectures in the Elastic Index client module. We will use Twitter index model for the generic type replacement for the Elastic Index client class. Then we can update receive methods to convert Kafka Aura models to Elastic models using the transformer class. And then simply call the Elastic Client save method, which will return a list of string of IDs as a result. Then let's log the results using an info message. Here, for the ID property of Kafka Consumer, I can actually reuse the consumer group ID configuration from the application config. So I will use Kafka consumer config dot consumer group ID property and read the value Twitter topic consumer from the configuration data. I need to do that, otherwise this ID property will override the Kafka consumer group ID. Because there is a property called ID is group, which overrides the group ID by setting it from the ID property. And this ID is group property is set to true by default, as you can see here. To get this consumer group ID in onUpStarted methods, I will also inject Kafka consumer config data using constructor injection and read the consumer group ID in getListenerContainer method so that I can start it manually here. I will also use objects require non-null methods for the Kafka listener endpoint registry to prevent null pointer exception when calling the start method. We can now run everything and see the tweets on Postman. But first be sure that you committed and pushed all config server repository changes so that new services configuration will be available in the config server. So we check the status using git status command, then commit all the changes using git commit command by specifying a message, and then push all the changes to remote GitHub repository. Then let's run docker compose up command to run Kafka, Elasticsearch, config server, and Twitter to Kafka service together. Let's check the logs if we can see the tweets in the console. Now let's use Postman to see if we can query Elasticsearch. To search an index, we can simply use /_search URI, and it shouldn't return any result currently. Let's now run Kafka to Elastic service in IntelliJ and then check the logs first. If it looks good and you can see the messages in the console, please go to the Postman and query the index again. And here we go. We have the tweets on the Elasticsearch. Now please also stop the Kafka to Elastic service and run with the alternative Elastic client implementation by changing is repository configuration. But remember to commit and push your change to remote GitHub repository before rerun the application. Note that config server also needs a restart after changing the configuration, because config server will load the configuration at startup. It is easier to change these configuration variables by passing them as environment variables, as we do with Docker Compose files. We will create the compose definition of this service in the next section. Alright, good job so far. I will see you in the next section.